Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Trimethylbenzene refers to benzene with 3-methyl CH3 groups attached to the ring. The molecular formula is C9H12. We need to count the number of distinct structural isomers by considering all unique positions for 3-methyl substituents on a benzene ring. Moving on to the next step. Label the positions on the benzene ring as 1 through 6. We need to place 3-methyl groups on 3 of these 6 positions, accounting for the symmetry of the benzene ring. Moving on to the next step. 1, 2, 3 trimethylbenzene, hemimylitine 3-methyl groups on consecutive carbons. 1, 2, 4 trimethylbenzene, pseudocumene 2 adjacent methyls and 1 separated by 1 carbon. 1, 3, 5 trimethylbenzene, mesitylene 3-methyl groups in alternating positions, symmetric. And for the final step, 1, 2, 3 is distinct from 1, 2, 4 and 1, 3, 5. 1, 2, 4 cannot be reduced to 1, 2, 3 or 1, 3, 5 by rotation or reflection. 1, 3, 5 is fully symmetric and unique. Any other combination, example 1, 2, 5 or 1, 3, 4 reduces to one of the 3 above by ring symmetry. Total distinct isomers is equal to 3, 1, 2, 3 trimethylbenzene 1, 2, 4 trimethylbenzene 1, 3, 5 trimethylbenzene. Why other options fail? A. 2 undercounts, misses one of the 3 distinct arrangements. C. 4 and D. 6 overcount, these arise from not applying ring symmetry correctly. Therefore, the correct answer is B. Therefore, the correct answer is option B.